Right, so let's start at the top here. We're on our Docker host with the Docker daemon running and no containers started. Right, let's take a look at the networking stack on our host then. Okay, we can ignore the loopback address, and we'll also pretty much ignore the ETH0 and the ETH1 interfaces. These are just standard Linux interfaces. I configured this VM to have two virtual NICs. These are ETH0 and ETH1. Nothing Docker specific about them. But this bad boy down here, this dockerO, what's the deal with this guy? Well, when the Docker daemon starts on our Docker host, it creates this dockerO interface. Only, it's actually a bit more than just an interface. It's actually a bridge or a virtual switch created entirely in software inside the Linux kernel. And dockerO is crucial to container networking, okay? So let's just make sure that we understand it's not just a regular old interface. It's a bridge or a virtual switch. Meaning, just like what we might consider a normal physical switch, it passes or switches packets between two connected devices. Cool, so it's an Ethernet switch, just one that's implemented entirely inside the Linux kernel. Bingo. But, right, quote unquote normal switches, well, they've got ports and devices attached to them, yeah? Well, if this thingy is 100% software, well, how can we see what's connected to it? Well, so long as we've got the bridge utils package installed on our system, we can see the details of dockerO with brctl show dockerO. Alright, so we can see the bridge's name, its ID, whether or not it's got spanning tree enabled, and a list of connected interfaces, which right now is a whopping 0. Well, that's because we've got no containers running, and as and when we launch containers, well, we'll start to see interfaces pop up on the output of this command. So let's go and do that. Let's fire up a container and dig a bit deeper.